Students, for today, we will look at the second learning outcome, and I would like to highlight some important reminders for application of differentiation based on parametric equations. The first reminder would be displacement is often expressed as a function in terms of st. Velocity is the rate of change of displacement, so the s dt or s prime t is v. Acceleration a is known as a is the rate of change of velocity, means a is dv dt or d square s dt square. A is v prime or s double prime. So please bear in mind what is the relationship between SV and A, as we have also looked into this in the previous lecture. And these applications are developed by Newton, and it contributed to development of calculus as well. Displacement, the first property, which is known with the symbol S, is normally represented by its position vector as this. Okay, and S is in terms of X and also component Y. This is relating to parametric function. I normally is attached to the x-axis, and J is the coefficient of J represents the y-axis. The distance from the origin is the magnitude of displacement. So magnitude, as you know, the formula is x squared plus y squared, third of x squared plus y squared. So same here, third of x squared plus third of y squared is actually displacement, which is, this is the symbol, the modular symbol of S represents displacement. Velocity is the next property that we're going to look into. Velocity basically represents particle, which is the rate of change of its displacement, and velocity can be represented in a diagram in such a way where we are aware that ds dt is actually v. So when we differentiate s from the previous slide, you will get x prime t and y prime t, and this is how we write the symbol. You can further actually shorten it to x dot I and y dot j. X dot here represents a variable that denotes differentiation with respect to time. Okay, and next, the speed of particle is the magnitude of the velocity. So when you need to find magnitude, is understood x squared plus y squared. In this case, the x is actually the x prime, and the y is also the y prime, and you set it. That's how you actually find magnitude. The direction of motion at any instant of time can be described with reference to x direction, because velocity is a vector quantity. It has both magnitude and direction. So you can actually describe it based on the x and y values. So therefore, the direction in terms of this diagram, when you look at this diagram, the direction can be referred as tangent theta equals to y over x. That is understood, opposite over adjacent. And y here is not just y, it has to be the y prime and the x prime. That's how you actually denote the direction. Now we will look into the third property, which is the acceleration. The acceleration of a particle is basically dv dt, means rate of change of velocity with respect to time. So therefore, A is v prime or s double prime. So in this case, just now, v was x prime t I plus y prime t j. So for now, when you differentiate the v again, you will get x double prime ti plus y double prime tj. So bear in mind, so we are considering the direction now. So therefore, you can shorten it to x double dot and I plus y double dot j. The magnitude of acceleration is, again, always when you want to determine the magnitude of a quantity, is just x squared plus y squared. So in this case, the x is the one with double prime and the y is the one with the double prime. So for this slide, we will look at an example. The motion of a particle is modeled by the equations x and y. Both of these equations are in terms of another equation, another parameter, sorry. So it's in terms of t. So therefore, this is a parametric equation. So you're required to find the speed of the particle and its direction after 1 second. So in order for you to do that, you need to determine, as you know, speed, the formula for speed. So you need to determine x prime t and y prime t. So you differentiate both of these functions. And now you identify the speed when t is 1. So when t is 1, x prime 1 is 5. Okay? And when y is 1, and you will get this value. So in order to find speed is, recall back, is actually a scalar quantity. So that's another indicator that you actually need to find a magnitude. Okay, so once you get the value of x prime and y prime, so you can actually find the magnitude of v based on our previous slide. So it will be x prime square plus y prime square and third, and you will actually get the value of the speed when the particle is after 1 second. So this is the speed value, and the unit is taken as meter over second. So you have answered the first part of the question. Is direction after 1 second. In order to determine direction, as I explained just now, tangent theta is y prime over x prime. So you have to find theta, y prime over x prime. So shift tangent value of this will actually give you negative 15 degrees or 165. So in this case, using the direction of x and y, x over here is actually a positive value to the right, and y is actually a negative value, so going downwards. So a resultant vector here will definitely be theta, which is negative 15 degrees. Because tangent theta has to be here because tangent theta is y over x. So logically, your direction will be negative 15 degrees. Now we will look into the second example. We are given the equations of a motion of a particle moving in a plane are given in terms of x and y, where x and y are measured in meters in t seconds. So since x and y are given in t seconds, so this is a set of parametric equations where x and y are given in terms of t. So find the magnitude and direction of velocity and acceleration after 3 seconds. So the magnitude of velocity, here, in order to find velocity, you need to find x prime and y prime. So as you can see here, x prime is 3t squared minus 3. Y prime is 2t plus 1. So when t is 3, x prime t is 3 is 24 and y prime 3 is 7. So the speed here, again, speed is scalar quantity, is definitely magnitude. So in order to find magnitude of velocity, it is x prime square plus y prime square. So you will arrive at this answer. And the direction, you need to find magnitude and direction. The direction of the speed will be tangent theta y prime over x prime. So in this case, we'll get 7 over 24. Inverse tangent 7 over 24 give you 16.3 or 196.3 degrees. So in order to find the right direction, you need to actually somehow sketch for the velocity based on the calculation. So x prime 3 is actually 24, which is positive. So the direction is this way. and then y prime 3 is 7, positive 7, so it's upwards. So the angle has to be here because tangent theta is y prime over x prime. So the tangent obviously has to be 16.3 logically. So direction of x and x prime and y prime, you can conclude that the direction of the velocity is actually 16.3 degrees. Part B requires you to find magnitude and direction for acceleration. So in order to find acceleration, you need to find x double prime t. So you differentiate x prime again and you get 16. And y double prime, you will actually reduce it to 2. And then when t is 3, x double prime 3, substitute t as 3 into here, you will actually get 18. And y double prime has already have a constant value, so therefore y double prime 3 will also be consistently 2. Acceleration, you need to find the magnitude of acceleration, therefore is x double prime 3 square and y double prime 3 square. You arrive at this answer. And in order to get the direction, it will be tangent theta y double prime over x double prime. So it will be 2 over 18, 18.1. You will inverse tangent 2 over 18. You will get your theta as 6.3 degree or 186.3. And in order to show the direction, you have to consider the location of x double prime and y double prime. X double prime direction is actually positive and y double prime is also positive. So therefore it is to the right and upwards. So theta has to be located here simply because tangent theta is y double prime over x double prime. So therefore theta has to be 6.3 degrees. Now we will look into second part of the application, which is related rates of change. So for example, when one variable x is a function of another, say in terms of u, then dx du equals to 1 divided by du dx. So the du dx will be flipped and will be equal to dx over du. So when y is a function of x, say fx, and both x and y are written in terms of u, xu and yu, then you can relate both rates of change of dx du and dy du. So for example, how the rates can be related with respect to x, dy dx will be dy du multiplied by du dx. So this part here is actually dividing by dx du. So you get your dy du from here, your dx du from here, and then dy du divided by du dx du, sorry, and you will get dy du multiplied by du dx. Now let's look at an example that involves rates of change. So a spherical balloon is being inflated at a constant rate of 240 centimeter cube per second. So this is dv dt simply because it is cm cube per second. So dv dt is 240. At what rate is the radius increasing when it is equal to 8 cm? So when r is 8, you are required to find dr dt. And for part B, at what rate is the radius increasing after 5 seconds? So you're also required to find dr dt when t is actually 5 seconds. So let's say we represent Vt as the volume after t seconds. RT represents the corresponding radius. So the question tells you just now dv dt is 240. The question for part A, the question required dr dt. So we have to come up with the chain rule. So whatever you're looking for, most of the time, you write it as a subject of the equation, which is dr dt. So from this, you know that you need to work out dr dt. So it has to be dr dv, because you can get v in terms of r, and when you differentiate dv dr and 1 divided by dv dr, you can get dr dv. Multiply by dv dt, because you're already given dv dt. So when you work out the chain rule, you have to depend on the information that is provided by the particular question. So for here, dr dt equals to dr dv multiplied by dv dt. Cross out the dv, your resultant will be dr dt. So in this case, first thing you need to work out dv dr and dv dt in order to determine dr dt. So therefore, volume is 4 over 3 pi r square, 4 over 3 pi r cube. dv dr would be differentiating this with respect to r. So you bring the 3 in front. It becomes 4 pi r square. So if dv dr is this, 1 divided by dv dr becomes dr dv. So 1 divided by 4 pi r square. Now, we need to continue to identify the dr dt. So in this case, dr dt is dr dv multiplied by dv dt. So in this case, 1 over 4 pi r square times with 240. We have the information. So therefore, it's 60 over pi r square. Then you're required to find dr dt when r is 8. So directly substitute r8 into the dr dt function, and you will actually get an answer 0.3 cm per second, correct to 1 decimal place. For the part B, you are given the information to determine dr dt after 5 seconds. So therefore, the volume has expanded 240 cm cube every 5 seconds. So you need to multiply 240 with 5. So this will be the new volume of the sphere. And based on the new volume, you need to identify the corresponding radius. So equate the volume to 4. We know the formula for volume is 4 over 3 pi r squared. Equate it to 1200. And solve your r. Your new r, your radius will be 6.59. And you can use this new radius to calculate your new dr dt. So substitute r as 6.59 into 60 over pi r squared, and you will arrive to a new answer, which is 0.4 cm per second, correct to 1 decimal place. A particle is moving in a circle of radius 5 meters and center is the origin. So therefore, the center has coordinate 0, 0, and the radius is 5 meters. When the particle is at this particular point, x and y, the rate of change of x, that means dx dt, with respect to time is 25 meter per second. So dx dt is 25 meter per second. Find the rate of change of the y coordinate. So rate of change of the y coordinate is dy dt. So the equation, so the question is just up to here, yeah. So this part here discusses the solution. Because the center is 0, 0 and the radius is 5, so you will arrive at this equation, which is x minus 0 squared plus y minus 0 squared. So it reduces to x squared plus y squared equals to
r squared. So 5 squared is 25. So this is the equation of the circle. So bear in mind, you need to identify dy dt when x is this and y is this value. So from this term here, when you apply implicit differentiation that you learned in the previous lecture, so differentiating x squared and y squared plus y squared equals 25, you need to differentiate with respect to t. Bear in mind, not x, not y, but with respect to t, you will arrive at 2x dx dt plus 2y dy dt equals to, differentiating 25 gives you 0. So the question gave you dx dt as 25. You can substitute dx dt here. It gave you x as this value, and it gave you y as this value. So you substitute x, dx dt, and y, and dy dt is what you're looking for. So you substitute everything accordingly, and you can calculate out your dy dt, which will be 25 sub 3, or you can write it in decimal, meter per second. So therefore, the y coordinate is changing. We are looking for rate of change, which is dy dt, at the rate of 25 over 3 meter per second.